The last three forms that we'll be looking at are the indeterminate forms of 0 to the 0, infinity to the 0, and 1 to the infinity. We'll be doing two of these three, but all three forms are approached in the same way. We're going to use the natural log to help us. So this first one, we're going to evaluate the limit as x approaches 0 from the right of 1 plus x to the 1 over x. This is in the form of 1 to the infinity. But what I'm first going to do is I'm going to let y equal 1 plus x to the 1 over x, and then I'm going to take the natural log of each side, which would give me the natural log of y equals the natural log of 1 plus x to the 1 over x. That allows me to bring that 1 over x down, giving me the natural log of 1 plus x over x when you multiply 1 over x times the natural log of 1 plus x. So instead of taking the limit of the original function, because presently it's not in a form that we can use L'Hopital's rule, it is indeterminate, but it's not in the form of 0 over 0 or infinity over infinity. My goal is to try and force it into that form. I'm going to take the limit of the natural log. That's the reason why we took the natural log. So we're going to take the limit as x approaches 0 of the natural log of y. Well, we just said y was equal to 1 plus x to the 1 over x, so we're really taking the limit as x approaches 0 of the natural log of 1 plus x over x. We now are in the form of 0 over 0, so we're allowed to use L'Hopital's rule. And again, we are approaching from the right here. Let me make sure I get my pluses in. And so I'm going to take the derivative of the numerator and the denominator. The derivative of the natural log of 1 plus x is 1 over 1 plus x. The derivative of x is 1. When I substitute 0 in, I get 1. Now the problem here is that 1 is not the answer because I did not find the limit of the original function. I found the limit of the natural log of that function. So if I have the limit as x approaches 0 of the natural log of y is equal to 1, so what I need to do is exponentiate each side by taking, so I would take the limit as x approaches 0 of e to the natural log of y would be equal to e to the 1. And again, taking both of these functions and raising e to them, saying exponentiating, e to the natural log of y is equal to y. So we get the limit as x approaches 0 of y is equal to e to the 1, or just e. That means the limit of my original function, because y was actually equal to 1 plus x to the 1 over x, that's actually equal to e. So in the end, when you are solving one of these limit problems that are in one of the exponential forms, you're taking the limit of the natural log and you're getting an answer. And that answer is always going to be the exponent on e. So the final answer really is just e to the 1. Okay, let's look at the next example. We've got the limit as x approaches 0 from the right of x to the x. I'm going to let y equal x to the x, and I'm going to take the natural log of y, and I'm going to take the natural log of x to the x, allowing me to bring that x down in front. Now I have the limit as x approaches 0 from the right of the natural log of y is equal to the limit as x approaches 0 from the right of x times the natural log of x. Now I'm in the form was 0 to the 0. I now have myself in the form of 0 times infinity. And this is a prior limit that we've already taken, but let's do the workout again. When you're in the form of 0 to 0 times infinity, your job is to rewrite one of the factors as its reciprocal in the denominator. So we'll get the limit as x approaches 0. So we'll have the natural log of x in the numerator, 1 over x in the denominator. Now we have converted 0 times infinity to infinity over infinity. We'll take the limit again by taking derivatives using L'Hopital's rule. So it's going to be the limit of 1 over x over negative 1 over x squared. We simplified this one in a prior problem. It gave us negative x. So the limit of the natural log of y is 0. But in the end, so we have the limit as x approaches 0 from the right of the natural log of y is equal to 0. We need to exponentiate each side. We're taking the limit as x approaches 0 from the right of e to the ln y. And e to the ln y is actually equal to y. So the limit as x approaches 0 of y is equal to e to the 0. In this case, it's equal to 1.